systems course. In this lecture that we will understand a raft. So in the previous part of this video that we understood what is a raft consensus algorithm, how it is used in distributed systems to elect a leader. So we saw how it is used for leader election. So in this section that we will see one more use case. The use case is log replication. So for example, we are going to build a simple cluster that consists of 5 nodes. Now these systems are connected. So this is the distributed system that are connected, and so what we are going to do here is that a client is going to send a log. The log that the client sends will be stored here. Let's say it's an M1, M2. In the sequence order that the logs are stored, persisted here. Also, each machine has its own state machine. State machine is for understanding purpose. It has its own state machine. So each machine has its own state machine. So whenever the client sends a request, the server N1, this is the leader. Yeah. Let's just imagine that it's already a leader. So leader election is already done. So we are sending the request to this machine, and the leader it's appending the data into the logs. Then it has its own sequence number, kind of like a log term number. It has some metadata about the logs that are stored and index of the data. So it will be sent to all the other machines, in the cluster. All the other machines are a number of machines. So we have sent the node N1 sent all the data into all the other machines. So what it's doing is it's replicating the data. So we have two things here, that one is synchronous and another one is asynchronous. So when the client makes a request, the leader N1 append the data into the logs, then send the request to the other machines. So other machines will append the data into their own log, then return the response. Then it will persist those data into the state machine, and finally it will return the response to the client. Here what we see here is that we are preserving the consistency. So once the majority of the nodes reply with the proper response, if the leader receives the majority of the vote, majority of the response, here more than 2 or equal more than 2 or 2, then it will append the data into the log. It will commit the data and send the response. The committed data will be persisted into the state machine. The same way, once the leader sends the response, all the data from the other machines will be committed into the state machine. Imagine that the state machine is just nothing but a permanent store, permanently maintaining the state of the machine. Now, this is synchronous approach. We can also try asynchronous. We can append the data and return the response, and asynchronously we can replicate the data. So either way, that only there is one trade-off. One can preserve the consistency, another one is eventually consistent. So if you go with the synchronous model, it's more consistent. And now if you look at that, let's imagine that there is due to network partition or failure, there is some lag in the log. So this one has not received the data for M2. Now we have a log data that is stored, but all of them are not in sync. This one is a log data that are stored, but some data are missing. So when the leader is elected again, due to some network failure, if all of them are trying to elect a new leader, we already see that how the process works. Follower, candidate, and leader. In the previous part of this video that we saw that how this process works in leader election. But here one more thing here is that what if the leader is elected but it has a data that is not up to date. So in those cases for for log replication, so leader should have the most up to date data. Otherwise the follower will not receive the most up to date data. So every time the leader election happens, so the leader should have the most up to date data. So we should only elect a leader node that is a leader if it has the most up to date data. So how to design this one? So whenever the leader election happens, it will send the metadata about the other things like a log. For example, if the machine N5 or N4 receives the request from N2 for the leader election, the metadata of M1, it will reject the request. So it will not be considered for leader election since it does not contain the most up-to-date data. So the machine that has the most up-to-date data will be elected as leader in the leader election. So that metadata will be exchanged in the leader election happens. This is how the log replication works. The distributed system using a Raft Continued algorithm.